All right, we're going to now look at that adiabatic temperature change, and this is the intro, and I know you will all read this, so listen along. Here we go. The usual way to warm and cool something is by adding or removing heat. However, there is another way to change temperature of a gas, and that is to change its pressure. As pressure decreases, the temperature of the gas decreases. This type of temperature change is called adiabatic temperature change. As air is pushed up a mountain, the air pressure will decrease and the air will drop in temperature. It will drop at a rate of 5.5 degrees Fahrenheit for each 1,000 feet. This is called the dry adiabatic rate. When the air has cooled to its dew point, water vapor will begin to condense as rain. As water changes form from a gas to a liquid, heat is released. This heat of condensation is added to the air and slows the change in temperature from 5.5 degrees Fahrenheit to 3.5 degrees Fahrenheit for each 1,000 feet. And this is called the wet adiabatic rate. So once condensation has occurred, once we've reached the dew point, we change from 5.5 degrees for every 1,000 feet we go up to 3.5. So it's really important. If we're in the clouds, the second you hit the clouds, then we start subtracting 3.5. But if you're just under the clouds, you're going to subtract 5.5 just to get into the clouds. And we're going to do that math in just a second. So let's look at the directions. And then I'm going to work through the first map with you in the next video. So on here it says we're going to start on the west side of the mountain, the wind side. Subtract 5.5 degrees for each 1,000 feet until the elevation of the cloud reaches dew point. Subtract 3.5 degrees for each 1,000 feet from the start of the clouds to the top of the mountain. Add 5.5 degrees on the way down the mountain, and it's only going to be 5.5 because you've already reached the dew point. You're getting, actually in this case, warmer, so we're not going to have to worry about dew points. So as we go up the mountain, until we're actually in the clouds, we're going to subtract 5.5. Once we hit the clouds, we're going to subtract 3.5. And we subtract 3.5 until we get to the top of the mountain. Then when we go down the other side, now we have to add 5.5 all the way over. So what you're going to figure out, if you think about that, if we subtract 5.5 and then 3.5, and then we add 5.5 all the way down, the actual other side of the mountain is going to be hotter because of the adiabatic temperature change, because it heated, but it increased in heat. And so what happens is you actually get a cloudy, wet side of a mountain, and you get the lee side or the dry side of the mountain. So watch the next video.